Actually, I prepared this for 1 hour, but I'll go through 20 minutes, okay, from now on. Because there is no equation at all, because I have not included any kinds of computational aspect. So it's very easy to follow. And if you have any the question behind it for development or calculation, any kind of things, so you can send the email to me, okay? Then I'll respond. Actually, the type of composite material is our second topic. Here you can say the PMC, CMC, MMC is the most typical classification. So actually, if we can say it's a intermetallic matrix composite, there's one more thing. But it's very rare case to be adopted, so it's deleted here. So PMC is a polymer matrix composite, CMC is composite matrix composite, MMC is metal matrix composite, and the hybrid composite is mixed acid means. So type of composite materials is a PMC case is bestly used in aerospace and automotive industries, because this PMC based one is very excellent properties can be expected, but its manufacturing technique relatively well established. So as an example, the mobility use the carbon fiber based matrix is very popular, but construction case glass fiber based polymer is most commonly used. And the metal matrix composite case, as a base material, the matrix material, aluminum is mostly used one. So aluminum reinforced with the silicon carbide, kind of this can be improved its stiffness, and the weight can be reduced, and so the durability can be extended. And the ceramic matrix composite case, so silicon carbide reinforced with the silicon carbide. Usually silicon carbide reinforced. Silicon carbide is as a fiber form. It's most the famous the silicon carbide fiber manufacturer is in company in Japan. So it's Nickel. Nickel is most famous one. So usually Nickel fiber reinforced silicon carbide, those kind of things. So actually that is one of my main material or system studied in PhD thesis. So if you have any question about that, just email me, then I provide some documentation on it. And as a base material of polymer, there's two classifications. One is thermoplastic, another one is thermosetting. Right? Thermoplastic is good for recycling. Thermosetting is not. So it's just volatile. Right? So thermoplastic one, as a thermoplastic can be heated and softened, then molded and shaped, so it can be recycled. So thermosetting is irresistible chemical bond reaction bond. So cross-linked and curing dual process to change phase from liquid to solid state. The cross-linking enables to eradicate component remelting with the application of heat. And the benefit is the recycled. So this is not recycled. So I think thermosetting-based composite is more better performance, I think. But due to its weakness in recycling is a little bit difficult to be adopted these days. And the classification based on reinforcement structure is a particle reinforced. Okay? And this is short fiber reinforced. And this unidirectional long fiber reinforced. This is bidirectional reinforced and the laminate composite and the open composite. This is a modernized one, okay, compared to the unidirectional laminate. And the braided. So braided composite also this is these two ones, woven and the braided one is most advanced ones among them. And the fiber reinforced composite materials. So glass fiber, carbon fiber is glass fiber. It's fabrication is very old, traditional one. So it's very well established and very cheap, but very good performance fiber. So if it can be applicable, this glass fiber is the best choice to save cost. And the carbon fiber one is its performance is best one currently. So if you wanted to, regardless of cost, if you wanted to best performance, then you should choose carbon fiber these days. And the aramid fiber is just used for very special textiles. So Kevlar is one of the aramid the fibers. So DuPont made available in early 1970s. And it's very good for high strength, good resistance, or something like that. So aramid fiber is very well used for fishing rod or golf clock. And the natural fiber reinforced composite is extremely popular for many uses in recent years because it's eco-friendly. Due to government policy and environmental consciousness, the use of natural fiber in polymer composite increased, especially in France. So polymer matrix composites. Polymer matrix composites are material made by embedding strong staple fiber or particle within polymer. So this PMC group, its mechanical property strongly depend on the fiber performance. So polymer, as a polymer matrix, the PMC backbone is just binder. It's kind of sticking together of fibers. And Somerset, so you can see the epoxy. Epoxy is the most widely used one. Epoxy, polyester, vinyl, ester resin, or thermosetting polymer solidified, irreversibly when cured. And the thermoplastics polymer is polypropylene, polyacetone. So very difficult to read in the hybrid matrices. So glass fiber. The glass fiber is mostly the bestly used one these days. So if we say FRP, in the case in the commercial market, everybody thinks reinforcement is glass fiber. There's carbon fiber ones, aramid fiber ones. It's well being used these days, and the advantage application PMC. Lightweight, high strength, design flexibility, corrosion resistance. So the overall, the comment can be found on slide. So you can asked to download this slide from the NIT Jalandhar professor. And the conclusion, as a middle conclusion, the possibility of a polymer PMC, as a PMC has revolutionized the industry by providing exceptional strength, lightweight, design flexibility. And the PMC, the vital role in shaping the future advanced material sustainable engineering solution, especially for the future of the personal mobilities, is trying to use bestly this kind of material. So property and application sectors, strength and stiffness, corrosion resistance, design flexibility can be classified issues. The strength and the stiffness polymer composite can be engineered to have exceptionally high strength to weight and the stiffness to weight ratio. And the corrosion resistance is very important to the application. So these days, because strength or other flexibility can be matched from any kind of advanced materials these days. So corrosion issue or especially electrical or thermal properties more concerned to the manufacturers these days. The CMC case, CMC is exceptionally high temperature stability is preferred, right? And the thermal shock resistance, thermal barrier, those kind of things, the CMC should be considered. And where corrosion resistance and the application. So CMC is because as I said in the lecture one, as my academic background, this is the main topic of my PhD dissertation from Corning and DuPont. And at that time, I was involved in Oriental Express project. In the case, so there is no lubricant for ceramic engines or something like this. So, so unique strength is it can be used extremely high temperature environments. Okay, so over 1500 Celsius also possible, 1500. Okay. So thermal shock resistance is very important issue. And the reinforcement and processing, so for CMC, it's continuous fiber particulate reinforcement processing method. So that kind of issue be examined. And high temperature capability, thermal stability, thermal shock resistance, and mechanical stability. So this kind of CMC materials, manufacturing technique is most sintering is included, and traditional part maker is the one of major manufacturers these days. So ceramic part manufacturers, they are going two different ways. One is for fine ceramics to semi the electronic ceramic materials, or the high temperature structural materials. Okay, they are finding either one. But I think the ceramics for electronics industry is almost is technology saturated. So if you are thinking about the ceramic industry for future use, I strongly recommend the CMC level, or especially nano particle reinforced ceramic is very important for the bio-compatible or artificial bone industry, or so even any kinds of mechanical component industry is need those kind of things. So, so strength and stiffness, this is metal and this is MMC case. As you see, so although the metal match composite has as a major material of composite metal, that means it's practically in volume ratio is about up to 80%, 7 to 80% is metal. Only less than 10% or 15%, those will be reinforcement. In the case, its tensile strength can be almost doubled, and the elastic modulus can be doubled. So the cost a little bit increased, but its advantage can be found easily here, right? And hybrid composite is combining strength, tailored performance application as needed. So the mixing of the more constituents can be combined together, not just the 2 materials or 3 materials. So multiple ones can be combined too, like Korean bibimbap. So everything you want to see the special property, then you can add and sintered or the manufactured, then check the property. And in the case you need to design your test setup, and you need to understand the measurement scales, and you need to understand how to calculate overall effective properties needed for. So that means you need to develop mechanical model to evaluate your newly sintered ones. So that means so a single research is single department research is not integral, I think. So interdisciplinary team is needed. So mechanical engineering and the material science engineering and sometimes physics, because of very nanoscale research also needed. So in that case, you can make a very the strong team to develop some kind of composite system. Okay. So combined material advantages, can find recoverability. Also, I have to finish it. Okay. So change. So that is about the PMC, CMC, MMC, something like that. But very interesting things. So these kind of things. So to make the theoretical model to evaluate effective modulus or expectation of ultimate strength or the toughness of that material, you must develop your theoretical model. And you can design the composite, because just to use that theoretical model before fabrication, before choosing your constituent or volume percent, you can check which one will be best. Of course, it is different from your final choice, but you can reduce your number of tests. Okay. But if you just think, okay, I can use a computational program to evaluate in case it is that is kind of a computational model, means just one model gives you just one result, like a test. Okay. So it is not appropriate to check the influence of any special parameter, okay? Because just one point give you as a result from computation. So That's why you need to collaborate with mechanical engineering model, a theoretical model developer or the professor in physics to make the theoretical model. Then you can save great time to develop optimal composite materials. Because if you don't imagine, but in my experience, let's say the most important thing, the delicate one, is coating export. That means the fiber or reinforcement, it cannot be embedded as it is. It must be coated to resist something. So that means it is a very special part of chemical engineering or very special part of the material science. So it's very difficult to find a good specialist in coating materials. But I can say to make very favorable interface or interface property from your composite material system, you must find a good coating specialist. Then you can, because the ceramic metal composite case in my days, so one Nickelon, it is 3 times coated, so with a different the material system, so that it can in the very toxic chemical environment or something like that, or it can improve the toughening characteristic at all. So I should emphasize PMC, MMC, CMC. The exact PMC. PMC is listed in the sense, but MMC or CMC, the fiber coating is very important to make the final property. Okay. This is about my very short second lecture. So if you have any question, then yes.
So what kind of reinforcement can we add to the metal matrix composite?
So in my case of silicon carbide fiber.
So in fiber form we can add?
Both of those. One is fiber form and the particle form. Yeah, I tried to with the Hyundai Motor Company to make aluminum matrix based the rotor, brake rotor. But aluminum itself, it cannot be used. It is the wearing too fastly, right? And its melting temperature too low. So we added the silicon carbide for particle inside. So it can be increased, but the final performance is not so great. So it is not used. But except I have experience to work with the Hyundai Motor Company ceramic matrix composite rotor. So it's so I gave them the three patents for CMC rotor. But so far I have not seen the Hyundai ceramic rotor yet. But at the time, the Porsche or those other companies already they use ceramic rotor. It's very expensive. The one set of rotor is about $5,000. So it's very expensive. At the time, Hyundai Motor Company asked me they wanted to make just $1,000 rotor. But it's very difficult to make. Anyway, usually there are many the material change potential requested by industry. So you can find if you have any special the interest in any part, then just think, okay, this is best material, or it can be replaced by new one. But the new one, if that property is like this, then it will be much better. Then how I can make this composite is the solution you can make. So I'll meet the lecture tomorrow. Right? Thank you so much.